Welcome back, everyone. This is seminar 4 of Ethics in Mathematics, which I titled Fairness and Impartiality in Algorithms and AI. In other words, those in France, because there are none. Who here is new? Who here has not been to an Ethics in Math seminar before? 1, 2, welcome. You're good. So you've missed quite a lot, but that's okay. Bring up to speed. The one thing I want to mention, which I think I mention every lecture now, is that these are sort of interactive-ish seminars. So if you do feel like you need to ask a question, you can. I won't be annoyed by that. The first 30-ish, and by 30 I mean for a very large value of 30 minutes, will be me sort of talking about the content I want to sort of get through, and then the remaining maybe sort of 20-25 minutes is really aimed at being an open discussion, because ethics is done like that. You can't just sort of do ethics on a board with some definitions, lemmas and theorems. You have to actually like talk about it and sort of work through ideas. And again, I remind everyone that when I ask you a question, please answer with another question. Do not take everything I say at face value. Do not think I'm always giving you enough information to answer the question I'm asking you. Almost always, there's something more you could poke and prod for. Okay, algorithms and AI. Well, this is going to be quick, isn't it? It's hard to sort of decide where to start. I'll try with some easy examples first, and then sort of ramp it up, just to give you a feel for where algorithms turn up in society and why they might not be as fair and impartial as you might be led to believe or might think. So firstly, our good old friend Amazon. And if you've been to a porter's lodge in Cambridge in the first week of term, you'll know what Amazon is. They're the guys that bring these boxes of stuff to the porters in like large mountains worth. You import stuff from them. They give you products, they list them when you do a search. Not always listed by price. They have a clever algorithm, a way to sort of present to you what you might want to buy. Especially when it comes to the buy it now box, they don't always put the cheapest thing in there. And you should actually check this. When you go on Amazon and you go and buy something, don't click buy it now, because that won't always be the, sorry, sit in those 3 seats because I've got the camera going, so that way or, not that one, another one. Anywhere else. Should take the seats away. So it'll, you buy it now, Amazon claims that it puts an item based on price, but also shipping, okay, rating, okay, and other factors that it wants to consider. And it decides what the best thing for buy it now is. Why is Amazon making that decision for me? Why does it think that it knows what the best thing to buy it now would be? Well, it doesn't. There's no guy in Amazon going, all right, I think this person wants this bottle of Coke or whatever. There's some algorithm running in the background. And someone's designed that. Someone sat there and gone, okay, this is how we should put something to buy in our box. They put their thought and effort into deciding what's best for you. And they've removed that decision-making process from you entirely. We as the customer are making a purchase, and this is based on decisions being made by Amazon. We're lazy. Everyone knows that customers are lazy. There's a button. I see a picture of or whatever, a box of beans, and there's a button, and I say, click this button, you get the beans. All right, click beans. Magic beans. Right? It's too easy. Amazon knows that. They take advantage of the fact that people are lazy. What about Google? Google runs an algorithm, a pretty big one. When you search for something, it doesn't just randomly give you answers back, it actually gives you something that kind of resembles what you searched for. It runs PageRank. Well, it runs something a bit different now, but it's based on PageRank. So the way PageRank works is that it takes all the web, so let's assume that your search happens to cover some list of pages. How do I decide which pages in the web are better than others? You can do maybe a number of words that appear in the page, right? But this is easily gained, right? Because say I'm selling, I don't know, shoes, I append to the bottom of my website 6 million copies of the word shoes, and then all of a sudden Google's like, hey, that's a good site for shoes. No, it's a good site that has the word shoes repeated 6 million times. Google's not stupid. So they say, well, let's make a clever algorithm. And it's called PageRank. What does it do? It ranks pages. The way it works is it needs to assign to each web page WI, assign a value VI, so the following holds that VI is equal to the sum of 1 over nj Bj for Bj in the neighbourhood of Vi. In other words, you've got web page I, and there's all these pages that point to it. Okay, this page has some value Vi. All these pages point to it. You take 1 over n of each value of each page pointing to it, where n is the number of things coming out of that page. You sum that, and that gives you the value for this. But of course, all this depends on the others. So you have to solve some giant system of linear equations. So what you end up with is one giant matrix, and you need to compute an eigenvector with eigenvalue 1. That's PageRank. And then you compute the value of each page, and then you pick the biggest one for your top search hit. So each page is donating 1 over n of its value to each page that it's linking to. So you can prove, using a bit of first year vectors and matrices, that this matrix actually has an eigenvector, and it has one with eigenvalue 1. Great, PageRank has a solution. Did I say anything about uniqueness? No. Unique solution in general. Sometimes you might have a unique solution, most of the time you won't. Okay, so you have this non-unique solution. Which one do you pick? You still might not have, yeah, these sum to 1, you still might not have uniqueness. So even if you assume that a page doesn't have value less than 0, you're still stuck. You now have to make a decision. How do you tie break? Which of these eigenvectors do you want to take? So even though PageRank seems nice and impartial and fair, hey, you know, everyone's donating the value to everyone else, hey, this is cool, look, everyone's happy, which one do I take? Easy to compute. Does that mean that's the one that we should take? You might be approximating as well, which will also add how would you like to approximate that? You have to make that decision. It's easy to say I've got this nice abstract algorithm that does it, but even this abstract algorithm requires more human intervention. Whatever that intervention is. We have to sit back and go, okay, this is not enough. We have to decide more stuff. That's probably what they do. I mean, that's what every company does, ultimately. It's a private corporation. It's there to make money. So it'll decide on the one that makes it the most money. How are those dodos going for you? Where's the impartiality? Where's the fairness? It's company. Doing company type things. Of course, the other issue is what is it selling, what's its product, but I won't get to that for now. So Google will make a decision based on what's best for Google. Not for you, for Google. Where is the fairness and impartiality there? It's best for Google, not best for you. Google recently changed some of its some of the ways it ranks news in light of this revelation that fake news is being circulating around. So it's decided ways to re-rank news. And it did this, and some news articles went higher up and some went down in the process. What qualifies Google to tell me what's more or less important? And they actually did this deliberately. Right? They changed the way, so they had a way of ranking news, and then they changed the way they're ranking news with this in mind. And in fact, they explicitly said that they, and the word is great, that they de-ranked some news pages. Russia Today was one of them. Sputnik News, I think, was another one. De-rank. Let's listen to that. De-rank. This is Orwellian language. Okay? This is Google saying, well, we can rank things, and we can undo it as well. We can de-rank them. No, what they really mean to say is that they censor, in a sense, these pages. Because if these pages start coming up in ranked positions 1,000 and below, or even 100 and below, they may as well be sitting at the bottom of the Mariana Trench. You're never going to find them. The top 10 Google hits is really the most important one. But even go down to whoever has ever gone through a Google search below hit 100. Below hit 1,000. Yep. One. Okay, so, and normally when you do a search, how many, it says, this is showing 1 to 10 of usually 10 to the 6, 10 to the 7, 10 to the 8 hits. So what proportion of the pages is Google showing? I think it's if you Google, I'm not sure how they're doing this. I mean, they don't tell you exactly how they're doing it. Right? That's the point. If they're pushing things below hit number 1,000, it's gone. It's basically being blotted out. You're never going to get to it. That's Google deciding what you do and don't see. So I think, well, maybe they're still doing it in the public interest, right? Maybe Google really, does care about, us seeing fake news, and so they're a good, friendly, good, clean, wholesome company. They were fined millions of dollars by the European Union for rigging their search results for their shopping sites over their competitors. They're not good, clean, and wholesome. They operate, we said, in their own interests. Whatever those interests may be. Don't think that this is necessarily being done in the public interest.